Hey guys, thanks for watching Beyond Science. It's Mike Chen. If you're like me, you are probably aware of and even intrigued by the North Atlantic Ocean's legendary Bermuda Triangle that is supposedly the cause of many aircraft and ship disappearances under mysterious circumstances. But did you know that space also has its own bizarre Bermuda Triangle nicknamed the South Atlantic Anomaly, or SAA? And to understand this anomaly, first thing you need to know, which is pretty obvious, is that outer space is not one of the friendliest zones.
Don't pander to me, kid. One tiny crack in the hull and our blood boils in 13 seconds.
It's inundated with many familiar and often unfamiliar threats, such as harsh cosmic rays. And these cosmic rays comprise of high-energy particles that are powerful enough to wreak havoc on living beings and electronic devices. Thankfully, the Earth possesses its own force field. It's basically two donut-shaped protective radiation belts known as the Van Allen belts that safeguard our planet's atmosphere from the potentially damaging cosmic rays. And at times, even additional transient belts may be created, as was the case in 2013 when NASA reported a third radiation belt, which was subsequently shattered by the sun's powerful interplanetary shockwave. These radiation belts were first discovered in 1958 and are named after James Alfred Van Allen, an American space scientist who first established their existence using his Geiger-Muller tube instruments. Now, the inner donut-shaped Van Allen belt exhibits a high concentration of protons. It begins at an altitude of 1,000 kilometers and extends to 6,000 kilometers above the Earth's surface. In contrast, the outer Van Allen belt is dominated by electrons and extends from an altitude of 13,000 kilometers to 60,000 kilometers above the surface of the Earth. Forming regions of intense radiation that encircle the Earth, the Van Allen belts comprise charged particles, which are electrons and protons, and is held in place by our planet's magnetic field. The source of a majority of these particles is attributed to the solar wind released from the sun's upper atmosphere, or corona, and high-energy radiation, or cosmic rays, that are primarily produced outside the solar system and also originate from remote galaxies. Situated above the Earth's atmosphere and in the inner region of its magnetosphere, these shielding Van Allen belts trap the energetic particles hurtling towards our planet and essentially protects our atmosphere from these particles. Now, what is the South Atlantic Anomaly? Well, the South Atlantic Anomaly, or like I mentioned before, SAA, indicates the zone where the Earth's inner Van Allen radiation belt dips so low that it comes hazardously close to the planet's surface at an altitude of approximately 200 kilometers, or 124 miles. The region where the inner mass of the high-energy particles makes its nearest approach to the surface of the Earth is traced to specific points over the South Atlantic and a few hundred kilometers above the coast of Brazil, areas where the planet's magnetic field is most feeble. Now, because of the low altitude of the inner belt, many spacecrafts, satellites orbiting in this area are exposed to magnified radiation levels owing to the region's heightened flux of energetic particles. Basically, these satellites are bombarded by the belt's stream of intensely high-energy electrons, protons, and atomic nuclei to such an extent that every square inch gets hit 3,000 times a second. This forceful pummeling can cause onboard electronics, such as laptop computers, to crash or malfunction and produce glitches in astronomical data. Moreover, a lack of preparation can cause unshielded spacecraft to shut down for weeks. Hence, shuttle astronauts who are set to travel across this mysterious anomaly are forewarned of this imminent danger and advised to shut down their computer systems while passing through the belts in order to secure their crucial data. This area is so intense that even the Hubble Space Telescope and some other spacecrafts are further engineered in a way that they can avoid possible damage to their delicate instruments by automatically switching them off during the times when the satellite makes their way through this area of intense radiation. Now, the damaging impact of this area, it doesn't just affect instruments or machinery. The SAA also has a detrimental effect on the visual field of astronauts who find it nearly impossible to capture astronomical observations while navigating through this danger zone. This is because of the disturbance caused by their fields of view by flickering, blinding streaks of light that produce no sound and are akin to sightings of unusual shooting stars. So now that we know that there is indeed a zone in space where our planet's safeguarding internal belt turns itself on us, let's understand the reason behind the dipping of the inner Van Allen belt to such a low height. As it turns out, owing to the Earth's equatorial bulge, its rotational and magnetic axes are not perfectly aligned with each other. In fact, they're slightly slanted at an angle of 11 degrees, and this leads to a concurrent tilting of the Van Allen belts, thereby causing the inner belt to fall to a dangerously low level above the Earth's surface. And because of the tilting of the belts, Earth's magnetic field is most forceful in the north and weakest at points above the South Atlantic and Brazil. And according to an analysis of the radiation data as performed by Riccardo Campana of Italian Institute for Astrophysics, it's revealed that the SAA is gradually drifting westwards and that its radiation levels are higher in its upper layers than its lower layers. Campana and his colleagues are now on a mission to devise a space telescope that will orbit the relatively less studied lower part of the SAA. He says most radiation models used in planning space missions are based on extrapolations from high altitude, high inclination observations. And the study of the SAA is really important because with spacecraft becoming increasingly sophisticated and more reliant on computers, in general more of them, the need to improve their resilience to the SAA and its strong radiation exposure is of paramount importance. I mean, can you imagine flying to Mars on vacation and all of a sudden, yeah, all the computers on your spaceship shuts down? That's pretty much going to ruin your whole intergalactic journey. And guys, if you want to hear more about unexplained locations here on Earth, we actually talk about the unexplained Dragon's Triangle located near the Japanese coast in the Pacific Ocean. And supposedly it contains a vile vortex that has existed for decades. And you can read more about this topic on issue 6 of the Beyond Science magazine. And to get the issue, just click on the link on the screen or in the description below and subscribe to the magazine for a 30-day free trial. Alright guys, until next time, I'll see you later.